thank you for coming and not going to the Xamarin and Angular and TypeScript stuff. I really appreciate it. Good morning. My name is Sasha, and we're here for the cool C++ libraries talk. I hope you are all C++ developers. You are, yeah, okay. Or at least doing some C++ occasionally on the side, something like that. Good. I do have a couple of questions for you so I get a good picture of what you're dealing with. Have any of you already been using C++ 11 or C++ 14 features? Yes? No? Not all of you? Some? Okay. There's a couple of other talks on modern C++ at this conference. I think I have one tomorrow, 9:30, on modernizing your C++ code. So using new cool C++ features. This one is on libraries though. So what I tried to do is just take a few nice libraries that I've been using occasionally in the past, and some other libraries which I'm really into and I teach a lot. So some of them I use every day, some of them I use more occasionally, and sort of build a talk around a few demos, just illustrating how these libraries can help you in your day-to-day C++ development. And I hope even if you're using lots of C++ libraries already, some of these will be new to you, or at least the core concepts will be useful. And the really nice thing about modern libraries for modern C++ is that they are all cross-platform, they sort of are expected to work everywhere, and they're all open source as well. These were important criteria for me as I selected the topics for this talk. Another question I have, are any of you doing cross-platform today? So is C++, is the reason you're doing C++ that you have cross-platform needs today? Yeah? Yeah? Okay, some of you. It's really weird, but C++ does have this whole portability thing built in. You have C++ compilers for microwaves and for smart cars and for everything. You can run C++ literally everywhere. And so, everyone's getting excited that you can do C# on Android and iOS. Well, you could do C++ on Android and iOS for years. And then you can do JavaScript on, I don't know, these Internet of Things devices and run Node on Raspberry Pi. You could run C++ on Raspberry Pi from day one. So, I mean, if you know C++, there's such an incredible breadth of devices and platforms that you can run on already. And the libraries I'm going to talk about today, well, at the very least, support Windows, Mac, and Linux. And some of them also support the mobile OSs and other weirder platforms as well. Essentially, wherever you have a C++ compiler, probably most of these libraries are going to work as well. Now, in terms of operating systems, Windows, yeah, okay, and you too? Yeah. Windows as well, okay. Linux, okay, thank you, my friend. Android as well. Okay, so as you see, I have a Mac, and some of the demos are going to be on Windows. Most of the demos are going to be on OS X. But they all work on all platforms, like I've said, and I've actually tried most of them, and they do. So what kind of things I have in stock for you? So I tried to sort of, address as many needs enterprise developers might have today doing C++. So we've got a library for HTTP client and server, building HTTP clients and servers in C++. It's a really cool library by Microsoft called Casablanca. Or the official name is the C++ HTTP REST SDK, which is a little more boring, but it's called Casablanca. Open source, Microsoft, and cross-platform. So it's a weird combination, but it's really a nice library. Google Test is the other. It's a unit testing library for C++, obviously by Google. Are any of you doing unit testing in C++ today? Great. So what are you using? Google Test. What's that? Uh-huh. CP unit and Boost. I was sort of expecting that. Great. So I'm just going to introduce Google Test to you in case you'd rather use that. And if you're not doing any unit testing in C++ today, then at least one of those libraries you guys mentioned should be worth looking into. Third one's Socky. It's anyway, it's the way I pronounce it. It's a SQL database framework, sort of like an ORM, really, object relational mapper, which has drivers or providers for most popular SQL engines today, including some NoSQL engines as well. So it supports, obviously it supports Oracle and SQL Server and Postgres and SQLite and MySQL, but it's also got support for some more exotic databases as well. Any of you using Saki today?
Did you mention Oracle there? I was just writing.
What was that?
Does it support Oracle as well?
Yeah, it does. Yeah. So any of you using Saki today? No? Okay, it's a really nice library. Then we have protocol buffers, which is another Google project, which has to do with serialization and communication, transferring data in the most optimal form, as well as storing data for later use. It's a really nice library, which is not only cross-platform, it also supports a bunch of different languages. It supports C#, it supports C++, of course, and it supports a bunch of more lightweight languages like Python and Perl as well. There's also a bunch of non-official bindings for a bunch of additional languages. So it's really sort of it's becoming the official language for all internal communication within Google, and lots of people outside of Google are using it as well. Anybody using protocol buffers today? No? Okay. And finally, we've got Intel's TBB, Threading Building Blocks, which is a pretty massive framework for concurrency and parallelism. It's the only one in this list that has sort of a dual license. It's GPL if you use it for open source work, and it has a commercial license if you intend to use it for commercial projects. The rest are usable in all kinds of commercial software, so they don't have any sort of restrictive licenses attached. Now, this is just a brief selection. I obviously could have picked another 6 frameworks to show you today. There's an abundance of good, high-quality C++ libraries today. And again, like I've said, most of them were from the start and are today open source. And so you can obviously review the source, but you could also contribute if you really like some of the things you're seeing. So with that said, let's just get started with a quick review of Google Test. So some of you already have unit testing frameworks for C++ today, so I'm just going to give you a quick review of what a Google test suite looks like, and then we'll move on to other projects which you should probably find more interesting. So Google Test is a unit testing library for C++. It's obviously made by Google. It's open source, and it's used by a lot of projects internally at Google, including Chromium, for example, and LLVM, which is the compiler toolchain by Google, used widely today across multiple languages. It's a really mature testing framework, which is, if you're coming from some other languages, from other testing frameworks for .NET, for Java, it should all look very familiar to you. It's the standard arrange, act, assert chain. You assert various conditions, and then there is a test runner which can tell you which tests have failed and why exactly they failed. There's a download link down there. I'm going to give you the slides, obviously. And it's a cross-platform framework, so let's take a look at a quick example of using Google Test on OS X. So here's the first demo. I've got a header file here, which has a small, tiny, can you all see the text? Great. Which has a small, tiny library, header-only template library, which can print containers recursively. So it detects whether something is a container. If it is a container, it prints out the container's elements. If it isn't a container, it just prints out the thing. So if you give it an int, it should print the int. If you give it a vector of ints, it prints out all the ints in the vector. And if you give it a vector of vectors of ints, it should be able to enter the internal vectors recursively. So there's a bunch of templates here, but eventually it all boils down to 2 methods. The one over here just prints out an element to the output stream, and this one over here enumerates a container and prints out the elements to the output stream. And I mean, it's an interesting implementation in itself, but let's take a look at the tests, because that's what I'm trying to show you here. So I've got an include for my header-only library, and then an include for Google Test, for the Google Test framework, and then I just have a bunch of tests. And the test macro declares a test with a test suite and a test name, and then obviously the code for that particular test, and we've got a bunch of different assertion macros that you can use to verify conditions. So, you know, unit testing at its best. And so I'm testing that I can take an int and dump it to an output stream correctly, and a double as well, individual characters, stud strings, vector of ints, vector of strings, an empty one, and finally a vector of ints. So a bunch of simple, super simple tests really. Let me run these tests just to show you the test runner. So this is the test runner, again provided by Google Test. You essentially build a C++ file without a main method. The main method is provided by the Google Test library, which runs all your tests and prints out which test is running, which test fails. Let me just artificially fail one of those tests. Well, suppose I put something in here. Okay, so now we have a failed test, actual /n. Oops, I mixed them up, but the expected output should have been just an empty /n, and what we got was a /n and then a 1. The test failed. You also have the execution times for the tests, and you have a test summary at the end, which says 7 tests passed, 1 test failed. So hopefully nothing surprising up to this point. And if you haven't been using any unit testing framework for C++ before, this is a good one to get started with. It really has minimal traction for getting started, for building simple tests, for running simple tests. If you have more advanced needs, it might be able to address them as well. Other alternatives like Boost Test, I've used Boost Test a lot. CPP Unit I've also used. So there are many options for C++ unit testing libraries today, and there is no reason why you should be doing unit testing in C# or Java, but not doing unit testing in C++. It's really a mature field at this point. So I'm just going to go on to the next framework, which requires a little more explanation, and that's Casablanca. That one is going to take a little more time to explain because the concepts here are much more sophisticated. So like I've said, it's an open source Microsoft library that runs on a variety of operating systems, including Android and iOS, and it gives you an HTTP client and, in the recent versions, also an HTTP server that you can build entirely in C++. It's a really nice library that Microsoft are already using internally a lot. They're even using it on Windows Azure. But it's also gaining some popularity in the open source world. It used to be on Codeplex. It's probably moving to GitHub at some point in the near future. Microsoft realized a while ago that everyone's on GitHub and they're moving away from Codeplex gradually to GitHub. I don't know, have any of you hosted anything on Codeplex ever? I hope not. So yeah, so everyone's moving to GitHub, and Microsoft is also going there as well. Casablanca is interesting because it's not just a C++ HTTP client and server library. It also has support for task-based asynchronous programming. And it's kind of one of the things you get in that package, which you can use even if you're not doing HTTP at all. It's a really nice implementation of task-based asynchronous programming for all various platforms. One major competitor is Intel's threading building blocks, which we'll see later. But with the thread building blocks, I'm going to focus on data-based parallelism. And here, I'm going to show you a few examples of task-based parallelism. So let me start with just a brief explanation of what tasks are and what task-based parallelism I'm talking about. And then we'll see an example of using Casablanca for HTTP. So with task-based asynchronous programming, we have a task of T class in the Casablanca library, which represents some operation running potentially in another thread and returning a value of type T. Now, if you're familiar with the concept of futures or promises, it's the same thing. So you can call this future of T, or promise of T, or async operation of T. Task T is something that runs potentially in a different thread and at some point returns a value of type T, an asynchronous operation that returns a value of type T. And you can do a lot of stuff with that task of T, which allows for a very clever composition. So first, you can obviously wait for the task to complete, to produce a value of type T. It's running in another thread and at some point produces a value. You can also get the value that was produced, naturally. But you can also do continuations or callbacks. So you can tell the task when it's completed, it should run a callback that you provide. It should run a continuation that you provide. And that allows for very nice composition where you have multiple continuations if you'd like. So I'm going to show you an example of this, and then we'll connect it back to the HTTP client and server concepts. So this is just a plain console application which has an include file for Microsoft's concurrency runtime, which is what Casablanca ships with as well. So I'm not using the Casablanca library here yet. I'm using header files which ship with Visual Studio. But if you'd like to run this on another platform, you could use the Casablanca library, and I'm going to show you that in a second. So I'd like to show you the basic task-based programming concept. So let's just start by creating a very simple task, a task of string. So I'm creating a task of string, and the constructor for a task takes a function or a lambda or a function object which will produce, in that case, a string. So I'm going to use lambdas here and just return hello world. So this here is a task which runs in a different thread and returns that string. The code, the return statement, executes in a different thread, and so if I'd like the value to be returned to my main method, I can do wait, to wait for the task to complete, or I can do get, which will both wait and return the string. Now, if you're not familiar with Lambda functions, just think of this entire block of code as another function declared elsewhere, which returns a string. So it's just another function declared elsewhere that runs in a different thread and eventually produces a string. And in our main method, we can synchronize with that task. So obviously here I could say, cout, the task is running, and so am I.
Could you add a sleep, just like 1 second to just make it
Yeah,
great
I'm gonna,
before
yeah,
return?
sure, I'm gonna do that. And then we do get, and I'm gonna print out the task returned and the text that was returned. And yeah, absolutely, I'm gonna add, I also need an include for std string, but also I'm gonna add a sleep here. So there's a bunch of ways to say sleep in C++. I don't want to bind myself to Windows, so I'm gonna use a standard library feature. C++ 11 has support for threads in the standard, although it's a very limited piece of support. But in any case, I can say this thread sleep 4, chrono duration, chrono seconds 5. The chrono namespace, by the way, is also new in C++ 11, and it's got a bunch of nice facilities for dealing with dates and times, including time durations and a bunch of arithmetic on times. And also high-resolution time measurement, which was always hard to get in C++. So we have a task that sleeps for 5 seconds and then returns hello world, and we have a main method that at some point synchronizes with that task. So let's just run this thing to get a brief idea of what it looks like. Okay, so the main method has reached the synchronization point, and now we're waiting for 5 seconds, and then the task returns, and the main method goes on as well. Okay, so this is like the super simplest use case of tasks ever, because it's not really different from just spawning a different thread and then joining with that thread, waiting for that thread to complete. But like I said, we could do a bunch of more sophisticated operations. For example, I can go over here and say, well, when that task completes, I would like you to do something else. So the main method doesn't want to synchronously block waiting for that task to complete. It just wants to schedule a continuation to run when that task eventually is done. So the then method has a bunch of overloads. The simplest one just takes a function again, which will run when the task completes. Now, it's a callback really, so what do you expect it to take as a parameter? The callback that we have to pass. The what?
String.
String. So this is again a callback, which takes a string, which is the result of the task. I'm using a lambda again. And so here I can say, cout, the task is done. And in the meantime, the main thread continues executing. The then method isn't blocking. I'm just scheduling a continuation to run when the task completes, and then I fall through. So if I don't want my application to end, I should really put a get char here or something to block till we get there. So if I run this now, the task is running and so am I, and we're now stuck at get char. 5 seconds later, the task is done and it prints out the callback, and then I hit enter and we're out. So this is interesting. This continuation passing style is really interesting, and you can combine a bunch of these things to compose tasks into more interesting units. So for example, one thing we could do, and that's what we're going to do in the next demo, is take a bunch of tasks, multiple tasks, and then wait for all of them to complete, and then do something. Or take a bunch of tasks and wait for any one of them to complete and then do something. So there's a bunch of composition scenarios that light up once you have this continuation style and not just blocking, waiting for a result. It's really a sort of a paradigm shift. Yes, sir?
How can you cancel the job or task?
Right.
Because if the client is out of scope now and not interested anymore, and you want to do a callback or two after it will crash.
Right. So there is support for cancellation, but it's cooperative cancellation. So you can't cancel a task which has already started and it doesn't cooperate with you. So if you have a task that calls an operating system method and blocks there, you can't cancel it. But there is support for canceling unstarted tasks, and there is support for canceling tasks if the task periodically checks back to see if it was canceled.
Just try to avoid the callback, basically. That's what we want to cancel.
Oh, yes. If you cancel the task, the callbacks aren't going to run. If they haven't run yet, the callbacks aren't going to run. Well, actually, you have multiple kinds of callbacks, which we don't have time to get into. You have callbacks that will always run. These are called task-based callbacks. You also have callbacks that run only if there is a result to produce. And these will not run if you have canceled. So there is more than it seems. The APIs are more complex. So we have basic callbacks now. And again, in the next demo, when we bring this back to the HTTP world, you'll see that we can take multiple tasks that are running at once and then compose operations on the whole set of tasks in really very interesting ways. But anyway, this task-based programming paradigm is now cross-platform. Like I said, Microsoft have open sourced this library and made sure it is portable and works on all platforms, including Android and iOS. And you can use it even if you don't have any HTTP-related needs. You can just use it as your favorite task-based programming library.
There's also a port for async task, which is the Java. Java, you've got async task in Android. Someone's done a C++ library for that, which is very similar to that.
Yeah, you mean the async task class in Java?
Yeah, but someone's done a C++ class, and it's almost identical to that.
I'm not familiar with
I'm just saying, as another alternative, that's another thing that's available.
Yeah, but okay.
Yeah.
Okay. But it is similar to lots of other languages as well. I mean, if you're doing C#, there is a very, very similar task class in the .NET framework. In Java, there are similar concepts. So yeah, everyone's sort of aligning with this idea of asynchronous tasks. Yep. Just one little thing I'd like to show you. There is also support for exception marshalling, which is another really, really hard problem if you're doing threading manually. So for example, if after 5 seconds I decide to throw an exception, I don't know, runtime error, boo. If 5 seconds later I decide to throw an exception, then a few interesting things are going to happen. First, my callback is not going to be invoked because there obviously isn't a string to be produced. So there's nothing to pass here as the result. There is no string, so the callback can't be invoked. The other nice thing that's going to happen is that if someone blocks and waits for that task to complete, they will get that exception marshaled to them. And it's easier to show. So let me just put a try-catch block here. Oops. I'm going to try waiting for that task to complete, and then I'll catch any exceptions that could arise, and then I'll see out task failed, exception message, what. And so this is really crazy because we have one thread which throws an exception and another thread which is going to handle that exception. And this is again all supported and provided by the framework. So if I run this thing now, then after 5 seconds, the continuation isn't going to be invoked, but the failure will be recorded, and the main method has been able to handle the exception that happened inside the task. And this is, again, a very interesting part of this library. It makes coordinating failure much easier. You can coordinate all your errors to a single central location where you really want to handle them, and not put error handling code in each task individually. It's, again, a big part of this value proposition. Okay, so enough about tasks. Let's take a look at the Casablanca library. So what I'm...
Quick question.
Yeah, absolutely.
Can you, like you've done with say hello.then, can you schedule something to handle an exception? So just say hello.onError.
Yeah. Yeah. So that's again, task-based continuations. What I can do is schedule a continuation which takes a task and not the result of the task. This continuation will always be invoked regardless of how the task ends. And so here inside, you can handle any exceptions. Yeah, so it makes things a little more complicated. And many people just have two continuations like that, one for success cases and one to handle errors. Okay, so I do have a ready-made project which uses Casablanca, but let me just show you the general setup experience if you're using Visual Studio, that is. The C++ REST SDK by Microsoft is available as a NuGet package. I don't know if you've been using NuGet for C++, but there is full support for NuGet packages in C++ now. So this is one of them as well. So let me just add the Casablanca library. Obviously, if you're on other platforms, you can just download it from Codeplex right now, GitHub at some point in the future. So there is a bunch of different packages, and the one we need is the last one, the C++ REST SDK. And as you can see, it was last published just a few days ago, so it's a really active project, live and kicking, and it's only got, well, it's just been 6 days, but it's got 14,000 downloads, which isn't that bad. So I'm installing it into my project. It could take a while to download this thing. It's a pretty big package, I think a few dozen megs, actually. So I'm not sure we're going to wait for it to come down, or I could just show you a couple of slides in the meantime. Yeah, so just the basic APIs, which again connect back to the task-based programming we've just been talking about. So the CPP REST library, the Casablanca library, is all in a CPP REST folder, and the header file you'll be using mostly is just http client.h. And then you have a bunch of really, really nice, well-factored APIs for being an HTTP client. So you have an HTTP client class, which takes a URL you'd like to access. And then the HTTP client class has a request method that can perform a variety of requests. So in this case, we call request with the get HTTP method. Now, you might expect the request method to just return a response. But as you can see here, it returns a task of HTTP response. So all the APIs in the C++ REST SDK are asynchronous. They all return tasks, and they run in potentially another thread. Now, to be completely accurate, these are I/O operations. So they don't really run in a separate thread. They're just performed using asynchronous I/O support. So on Windows, we have asynchronous I/O support. On Linux, you have it's based on libuv. So there's a bunch of variety here. But the idea is you're not burning a thread to wait for a network operation. It's performed asynchronously, and the callback is performed when the operation is done. So this is all expressed really nicely in C++ using the task class, which we've already seen. It's the same thing, it's the same class, except there isn't necessarily a thread behind it, but just some general concept of an asynchronous operation. But you can do the same things with this task. You can wait for it to complete. If there's been any exception, you get it marshaled to your main thread. And you can schedule continuations as well using the then method. And the task is of HTTP response, so your continuation should also take an HTTP response. And I hope you see how lambdas really make this whole thing much nicer to write. You don't have to, put your callbacks in different methods. You can all do it in JavaScript style.
Does it support chunks?
Hmm?
Does it support chunks?
Oh, what's that?
Does it support chunk data?
Chunks, yeah, it does. Yes, so it's downloading rather slowly, so I'm just gonna switch over to my other Visual Studio instance where I already have it configured. And the demo I'd like to show you has to do with getting the weather from an online weather service called Open Weather Map. Now, this is a little console application which, when run, will try to retrieve the weather from multiple cities and then print it out to the console. Let me show you a quick example of what it looks like when it runs. So I can say London, Paris, Jerusalem, Omsk, and I don't know, Tokyo. And there it is, 5 degrees, not sure, but anyway, it prints out the weather, the temperature, sorry, and the weather conditions. I'm not doing any formatting, so you know, the capitalization of sky and clear is not my fault. It's just what I'm getting back from the service. So the interesting thing here is that we're running all of these tasks in parallel, and we're printing out the results in order of completion. So it's not like I'm waiting for all 5 to complete and then printing out the weather. I'm waiting for the first one that's done and then printing out the result, then waiting for the second one that happens to be done, printing out the results, and so on. And in this particular case, Tokyo seemed to be the first one that had a result available, even though it was the last parameter provided. So going back to the code, let's try to build this thing actually. So I'm going to delete a little code and then try to reconstruct it together with you. So first, I've got this getWeather method, which isn't really that interesting. It uses the HTTP client class, which I've shown you before in the slides. It accesses API openweathermap.org. And then it builds a URL which goes /data/2.5/weather with a query string Q, and then the parameter itself is the city. And then we just do the HTTP request, and the method returns, again, it's kind of obscured by the namespaces, but it returns a task of HTTP response. So it's an asynchronous operation which will eventually produce an HTTP response. Okay, the other building block I have here is a function that converts Kelvin to Celsius, because the service returns temperature in Kelvin. So we have to convert it to Celsius. And finally, there is a method here which we'll be using called printWeather, which takes an HTTP response, which was already provided by the server, and then tries to parse its contents. And here, again, there is a nice building block which you can use even if you don't need the HTTP SDK, and that's the JSON parsing part. So there's support within that library for parsing XML and for parsing JSON. And specifically for JSON, there's a bunch of really nice convenience methods. Now, specifically, if you have an HTTP response, and you know the body is a JSON object, then you can just call extract JSON to get that JSON object. But the really nice thing is that if you look at extract JSON returns a task of JSON value. So it is also asynchronous, because there's potential for this extraction operation to take a while. So this operation is also asynchronous. And so I call get here to actually force it to be synchronous, to retrieve the result right away. But since it is a task, I could have scheduled a continuation. I could have processed the results at a later time. Now, the rest of it is pretty self-explanatory. So JSON has @, methods to get at the internal JSON objects. There's support for JSON arrays and strings and doubles and dates, all the various JSON-supported types. Now, so let's take a look at the interesting part over here, which is where, well, I'll just uncomment this, just in case I'm not able to reconstruct it that easily. So we have a collection of cities for which we'd like the weather, coming from the standard, from the process's arguments. And then I create a vector of tasks of HTTP responses for all the tasks I will have running in parallel. And now, well, for each city, in the vector of cities, we'll use the getWeather method from above to get the weather at that city. Now, getWeather at city, if you look at the signature, returns a task of HTTP response, so it's one of those asynchronous operations running in parallel. So I'm going to put it in the pending responses vector. Okay, so at this point, we have, say, 5 of those HTTP requests in flight, and they're all sitting in this vector. And so now we have to orchestrate this process of waiting for the first one to complete. And there is a really nice helper called whenAny that we're going to use. Now try to ignore the template horror of the signature, and I'll explain what it does right away. The basic idea is that when you have a collection of tasks and you'd like to do something when any of those tasks is done, you use whenAny. If you have a collection of tasks and you want to wait for all of them to complete, you use whenAll. So whenAny takes iterators. whenAny takes iterators to the set of tasks that you'd like to wait for, and it returns, rather surprisingly, another task. So it doesn't do anything clever on its own, it just returns a task that represents the completion of the first task in that list of tasks. So let's see the type. The type of that t variable, as the compiler can deduce for me, is a task of pair of HTTP response and size t. So it's a task. It's an asynchronous operation that's running elsewhere, and the result it produces is a pair. Now, what are the constituents of the pair? The first element is an HTTP response, and the second element is a size t. Now, the HTTP response is just the result of the first task that's done. What could the size t indicate? The index, right. Which one is done? So which task has completed? So I'm getting the HTTP response from the task that's done, and I'm getting the index of that task as a size t. So that's why the signature is so convoluted. You have a pair of a HTTP response and an index. So let's just say that explicitly. So this guy over here is a task of pair of HTTP response and size t. Are there 3 of them? 2 of them? I don't know. Right. So that's the signature. I hope you see why I used auto just before. But once we have this thing, we can, again, it's an asynchronous operation, so we can wait for it passively, or we can schedule a continuation. For simplicity, I'm going to wait passively, so block. This returns, let me spell it out again, a pair. Oops. This returns a pair of HTTP response and size t. And once we have that pair, I can print out the weather at pair.first, which is an HTTP response, and we know which one was completed, so we can remove it from the vector of pending responses and just do this thing over. So I can do pending responses erase, pending responses begin, plus pair.second. Pair.second is the index of the one that's completed. And then I can just wrap this whole thing in a loop that says while pending responses size is greater than 0. And I think I've reconstructed what we had down there before. So we have a collection, we have a collection of tasks running in parallel, and then we wait for the first of them to complete, not necessarily the first one in the vector. When it's done, we print out the weather, and then we wait for the next one until we exhaust the whole list. And this is an example of the composition facilities we have here. This whenAny helper method is really useful for this kind of thing. And if I wanted to, I could get rid of all the synchronous blocking calls here, right? So I could get rid of this get call, which essentially introduces blocking. But that makes the code a little more complex. It's doable though, but it's a little hard. So let me just see if I've successfully built the same thing now. Okay. Yeah, seems to be okay. And you'll notice that it's now coming in the same order as provided in the command line arguments because the results are cached already. So it's using HTTP caching, obviously. Great. Let's take a look at another demo of Casablanca, and then if you have any questions. I've mentioned that in recent versions, there's also support for an HTTP server, not just an HTTP client. And I have a really, really super simple example of this here. So there is another header file for HTTP servers called http-listener.h, and this one gives you a nice API for listening to HTTP requests and processing them. Now, it's not an MVC framework. It's nothing like, you know, ASP.NET or Express or Sinatra. It's Ruby on Rails. So it's not a whole web server framework. It's just an HTTP listener API at this point. So you can take in HTTP requests, you can do some processing, and you can render HTTP responses. But there is no view engine, templating engine, routing, all of these concerns. It's not supported right now. So this is a really super simple example. I create an HTTP listener, which listens on localhost port 9841. And then I say listener support, which is how you say what should happen to individual requests. Listener support takes, again, a function which takes an HTTP request and calls reply at some point to provide an HTTP response. There is, of course, support for JSON and binary data and also streaming. So you can open, say, a file and stream that file into the response. But here I'm just replying with a static string, hello world, and status code 200 OK. So I have it already compiled down here, so let me just, oops, I think it's over there as well. Let me just run it quickly. So we're listening, and if I go to this magic port, oops, wrong one, then we get the hello world back. So there's your HTTP server in C++ in about 6 lines of relevant code, which is rather impressive in a way. But again, it's not a full-fledged HTTP framework. There's still lots of parts that you'll have to fill in. But it's still pretty incredible you can do this in C++ today. Yeah?
Security, can you basically identify the calling user?
Oh, you mean basic authentication or anything?
Basic authentication.
There isn't right now support for basic authentication, but there will be. More sophisticated protocols like WS star security, I don't think so. So it's really intended to be a simple HTTP listener, and you can put stuff on top if you like. But at this point, there's just really very, very basic support for HTTP. Okay. So this is Casablanca, the REST SDK, and the whole task-based programming paradigm. And we have a few more demos, so I'm just going to move on, unless you want to ask anything else. Yeah? Okay. So Saki, a really nice object relational mapper for C++, which I'd like to show you next. Saki is an open source library, which isn't quite as well maintained over the last few years, but it's a very stable library anyway, which has support for a bunch of different database servers, and it's pluggable. So if it doesn't have support for your favorite database, it is, well, theoretically possible to develop support as well. It works on Windows, OS X, and Linux. There are some attempts to bring it to mobile, such as Android and iOS, because it has support for SQLite, which is the database that most people use on iOS and Android. It has built-in support for SQLite, so it's definitely possible to compile on iOS and Android. The URL here is again, the URL is there again, and let me just show you a quick demo instead of looking at code on the slides. So let me first show you the database. So this is a simple sample database which has albums and artists and genres and tracks and playlists and also, for some reason, employees and customers and invoices. But the interesting data is in the album and artist and genre tables. So, for example, we've got a bunch of albums here and a bunch of artists in here. And we'd like to build a simple C++ application that does some basic operations, manipulation of that SQLite database. Now I'm using SQLite here because it means I don't need any configuration. I just bring in the file, the single SQLite database file, and I can start working with the database. So let's review a couple of basic operations first, and then see that Saki can be used as an object relational mapper and not just a raw SQL engine. So here's my source file, and we'll take a look at the object relational mapper later, but first let's start with the basics. So to open a database session, you use the session class from Saki, and it takes a provider as a parameter, and then in case of SQLite, just the database file name. For other databases, this would be the connection string or any other information that indicates where the database is. And then let's take a look at some basic operations. It's really a rather bad example of operator overloading, so using operator overloading for all sorts of unrelated things, but it does end up being quite readable in a way. So let's take a look at the first example over here. So I'm saying SQL, which is the session, select count star from artist, comma, into count. Now, this is the overloaded comma operator, which isn't something many people do in C++, but it is possible to overload the comma operator, and so that's what they're doing. And this constructs, essentially, this whole segment over here, constructs a query and the output for that query, and pipes that through to the SQL, to the session object. So this executes the query and puts the result back in the count variable. And then we print that out. We have this many artists in the database. And then I ask the user for an artist name prefix. So I'd like to filter the list of artists I have and then show the albums of that artist. So I take in the name of the artist over here, and then I have a vector of string with 100 albums, with 100 album titles that I'd like to read from the database. So again, the query here is select title from album artist, where album artist ID is equal to artist ID, and artist name is like, and this is a query parameter. So there is support for those as well, for placeholders. So it's colon artist, and then again this beautiful comma operator and the use function, which says, well, bind that artist parameter to the artist name that you read from the standard input and the % character for the like operator to work. And again, the output of this query should go into the vector of strings. Album titles specifically, which I'm retrieving, album titles are strings, so I'm just reading them into a vector of strings. Obviously, there's support for limiting the number of results. There's also support for unbounded result sets, right? So a vector has to have bounded size, but there is support for paging and all kinds of operations like that. So as long as your types are primitive, the things you're querying are primitives, you can just go along with this approach. I could even say select the title of the album and the name of the artist into two separate vectors of strings, right? So it's definitely usable, even if you're just using the basic standard types. But it's even more interesting if you want object relational mapping capabilities. Now this is C++, so there is no reflection or anything clever of that sort, but you can build a helper class, a helper template really, that tells Saki how to map data from a database query back to an object of your choosing. So that's what I did here. I have a track struct, could have been a class of course, that has all the properties for a track. So track ID, name, album ID, a bunch of other interesting pieces of information. And next thing you do is you specialize a class template called type conversion. This is provided by Saki. It's a template specialization, so it really has to sit in the same namespace. So in namespace Saki, there is a template specialization for type conversion of track, of that specific type we have just declared. And then you just implement two static methods, from base and to base, which convert from the database representation to a track, and from a track object to the database representation. And this is done by hand, right? So this is annoying. You could obviously build a generator, and Saki does have basic support for those, that will generate these classes for you, given a database schema. It's obviously pretty repeatable code that you can imagine being generated automatically, but you do have to write it in one way or another. So once we have that horrible conversion template, which I'm not going to review in detail, I can do stuff like this. So I can build a row set. Let me just put some new lines over here. I can build a row set of tracks, prepare a query which says select star from track album, where track album ID is equal to album ID, and the title of the album is a query parameter. Use albums at index 0, so I want to print out the tracks in the first album which I've retrieved previously, and then this just executes the query, and we have this row set which is lazy loaded, so as I enumerate it, it will do paging as well. And we just print out the tracks. So this is a container of tracks. The object relational mapping is done by this template specialization that we built. So it's quite a bit of work compared to, I don't know, using Entity Framework in .NET. But it's definitely easier and more maintainable than writing all your SQL queries by hand and doing all this parsing and manipulation back to objects. If I run this thing, just to give you a quick example, so we're asked for an artist name prefix. Let's go with Qui. These are the albums we have for that artist, and these are the tracks in the first album. So we have just accessed the SQLite database from C++. Again, not that many lines of code, if you don't consider the conversion template, right? So if you just want basic queries with no mappings, it's really just a couple of lines to execute queries, and the same also applies for insert operations, delete operations, all other kinds of SQL statements. It's a really, really nice library. Again, support is kind of dwindling, so not support, active development isn't so active recently, but it is pretty stable, and if it works for you, if it doesn't have any missing features that you really, really need, I really recommend this over anything manual doing SQL. Okay, we have a couple more coming up, so this is the Saki demo. And that's protocol buffers and TBB, just two more libraries to go. Protocol buffers, which I've mentioned at the beginning of the talk, is a really nice library by Google for very, very fast and portable serialization of data. Serialization and, of course, deserialization as well. It's said to be 3 to 10 times smaller than XML, but then XML is a pretty horrible format size-wise. And it's also said to be 20 to 100 times faster than generating XML. But it is also obviously faster and more compact than JSON, for example. It's comparable with binary JSON and other more compressed formats, but again, it's designed to be extremely fast to serialize, extremely fast to deserialize, to parse, and it's also designed to be very compact in the representation. So it's a binary format, no extra fluff, text headers, closing brackets, nothing of that sort. There's support for C#, Java, and Python, which are the 3 languages Google uses internally very heavily. There's also unofficial support for C#, but it's kind of almost official. It's a Stack Exchange library. The people behind Stack Overflow, they're maintaining one of the major protobuf implementations for C#. So it's a pretty stable library, which is, again, extremely fast and works really well. Now, the interesting thing about protocol buffers is that the serialization and deserialization code is generated up front. So it's not like, say, data contract serialization in .NET or object output stream and object input stream in Java. There is no reflection at runtime. All the necessary code to do the serialization is generated up front. So serialization is obviously extremely fast. You have to, however, perform a pre-compilation step to generate this serialization code. But for C++, it's kind of obvious, I suppose. You don't have reflection in the language, so you have to pre-generate the serialization code. Now, the common format for all of these languages is the protofile. And this is a simple text file which describes your message format, the types you have, the stuff that you're going to be serializing. So this is obviously language-independent format. So you could be using C++ on one side and Python on the other side. That's exactly the demo I'm going to show you now. And the only thing they have to share is this protofile, which declares the message format. And protofiles are, well, it's a really nice format. There's also multiple versions. But essentially, you have messages, which are kind of like classes or structs, the types that you want to serialize. They have fields inside, which could be required or optional. They could be single values or collections. And of course, they could be composite types. So you could have, say, a line item, which is contained in an order type. And then there's support for enumerations. There's support for default values. There's lots of additional features, obviously, around this. From this protofile, you generate the serialization and deserialization code for each language that you plan to use. So for C#, you generate C# code, for C++, C++ code, and so on. Oops. So let's see a quick example of this. This is straight from the tutorial, actually. So this is the protofile. And it has a person message, a person type, if you will. A person has a name, an ID, an optional email string, and then we have a phone type enumeration. It's internal to the person, so you can only use a phone type inside a person. But of course, if you wanted to share it, you could put the enum outside the person message. And then we have another message, which is also internal to the person message, and that's phone number. A phone number well, has a number as a string, and an optional phone type, which has a default of home. So if nothing is provided, it's going to be home. Now, these numbers you're seeing here, these aren't default values or anything of the sort. These aren't values for the fields. They are just serial numbers that you have to assign each field. And this allows for backwards compatibility. So if you add additional fields, and even if you reorder the fields in your protofile, if you keep the same numbers, then your message format remains backwards compatible. So if there are extra fields in the message you get, you can ignore these extra fields if you don't understand them. And that's why the IDs are necessary. So in any case, the person message has a repeated collection, so a set of phone numbers. And finally, an address book is just a set of people, just a set of person messages. Okay, so now let's take a look at what the compiler would generate here. So I've got a makefile that starts by running the protobuf compiler. And the protobuf compiler is, again, it's part of the protobuf package, of course. You give it a language for which it should generate these automatic serialization and deserialization files. So let me, let me go to the protobuf folder and make build. Okay, so at this point we have some extra files over here generated by the protobuf compiler. These are for C++, and this is for Python, because I intend to use Python as well. So the C++ files have the obvious auto-generated warnings, do not edit, do not modify. And there's a bunch of code here, of course, which is generated from our message and person, and I think, could be better, thanks, yeah. Generated from the message and person and phone type types. There's also a C++, thank you. There's also a C++ file with implementations for those. You see it's a lot of code, but it doesn't have to be pretty or anything. And for Python, same thing. This is generated by the protobuf compiler, a bunch of Python code that will serialize and deserialize these messages. Okay, so once we have that generated, I can show you the serializer, which is a C++ application, and then the deserializer, which is a little piece of Python script. So to use protobuf, you just include the auto-generated header file. It does all the rest internally. And then you create objects. So I create an address book object. Notice the namespace is coming from the package declaration and the proto file. Doesn't really matter. So address book is the message type. And then we create a person object using the address book add person method. And then we set some properties on the person object. And then we add a phone number, and we put a value in that phone number, and a type, and so on and so forth. So there's a bunch of generated methods to manipulate the message and to manipulate any internal collections and objects you have in that message. And finally, there's support for serialization. So you just say serialize to OStream, and you push this thing out, in this case, to a file. If I run this serializer, the generated file, oops, it's right over here. The generated file is not designed to be human readable, but some parts of it you can read because they are strings. So the phone number is a string, the name Dave is a string. Rest of it is, as you can see, unreadable, non-readable characters. And now for the Python script, just to show you that this really is a portable library. So on the Python side, you have a Python package address book pb2 generated by protobuf, and then there is an address book constructor which creates an address book object, and it can be parsed from a string or a file. In this case, the file is addressbook.bin, which we have just generated. And then the address book has a collection of people, and there is support for enumerating them in Python and for accessing their properties. Well, again, same as C++ pretty much. So it is really an interoperable, a portable format. Let me just show you the script for a second. So if I run this Python script, it successfully retrieves Dave from the file and prints Dave's phone number. Yeah.
Can we add compression to it? Because I was looked at the string, it was just basically the text.
Yes,
file.
well, the strings are not compressed. It would make parsing slower. You can obviously add a compression, you know, in your wire transfer format, but the format itself does not include compression. It just tries to pack things as effectively as possible in terms of, an int will just take 4 bytes and not be printed out as a series of digits. But other than that, if you want to add compression, you should add it yourself. It's designed to be as fast as possible. Mm-hmm.
Been using Apache Thrift. Any idea?
What's that?
Have you used Apache Thrift?
Yeah, well,
Seems very similar to
right.
that,
Thrift, yeah, Thrift used to be a Facebook project.
Yeah.
Yeah, now it's an Apache project. Yeah, pretty much same design. So same idea. You have a Thrift file from which you generate serializers and deserializers.
So the difference, I see, can you switch out the format on the wire, for instance? So with Thrift, you could switch out between binary transports, or you could have a serialized JSON format.
Yeah,
sort
well,
of thing.
Thrift indeed is designed as it's more than just a serializer, right? Thrift is really a messaging framework as well. Protobuf is not a messaging framework. It's just a serialization format. So it's like a JSON reader and writer. It does not include any support for custom formats or anything of that sort. It is really just solving the problem of serializing and deserializing data and making it portable between languages and operating systems.
It's more important one actually. If the format of the message changes, let's say obviously not taking things out or renaming them, let's say you want to add a new property. I mean, does it hurt? Because all the header files are auto-generated. Is it going to break?
Right.
The code?
Yeah, so that's exactly the reason you have the proto file specify these numbers. So if you add a field, you will not break the older format. So a newer parser can parse older files if you have optional fields, and an older parser can parse newer files if you have extra fields you'd just like it to ignore. So as long as you don't, make this thing an int without changing the numbers, it's backwards and forward compatible.
I think you can't go from, for example, from optional to required either.
You can, but it has the potential of breaking. I mean, it will only break if the optional thing isn't there. So it's not going to break, if the optional thing is there. It will successfully read the optional thing if it's there. But if it's not there, then yeah, making it require will break.
Because I'm just about to implement something that in a couple of weeks' time, and this looks quite good.
Yeah, it's probably better than what you and I could implement in a few weeks' time. And it has support for a bunch of languages, which I'm not sure was a design goal for you. Okay, so that's part of buff, and we have just one more left, which is good. We'll have time for questions as well, and that's threading building blocks. This is a pretty big, this is a pretty big library by Intel, and there was actually a talk yesterday by a couple of guys from Intel about Intel's parallel tools and profilers and the parallel building tools, the parallel libraries that Intel has. Here, I'd like to focus specifically on a library by Intel called TBB. Intel also have language extensions for C++ and pragmas and OpenMP support, and they have their own C++ compiler and a bunch of other tools that help, which can be useful for C++ developers. But this is the only library from Intel that is, well, it aligns with my goals in building this talk in terms of being cross-platform, library-only, standard modern C++. So it doesn't require, using a specific compiler on a specific platform only. It will work on Windows, Mac, and Linux. Now, TBB has a huge number of features. It has support for task-based parallelism, kind of like what I showed you before with Casablanca. It has support for synchronization, concurrent collections, parallel algorithms like sorting, reducing, transforming data in parallel. It also has support for parallel loops, which I'm going to show you in the demo. And there are some more advanced features as well. For example, if you need a super fast concurrent memory allocator, then TBB has one for you. If you need access to low-level instructions for implementing your own synchronization mechanisms, TBB has that covered. So it's really, well, Intel, they know a lot about building multi-core applications. They know a lot about the low-level stuff. And this is a pretty good concurrency library. The only problem is it's GPL if you want to use it for free. So it basically binds your whole project to the open source license, to GPL, or there is commercial licensing available from Intel. So let's take a look at a brief example where I'm going to use parallel algorithms and concurrent containers. TBB, there we go. Okay, so as always, the setup is pretty easy. There is a big folder you get from Intel with header files and library files for each platform, of course. They do also ship source code if you'd like. Like I said, it's open source. I'm including tbb.h, and that's pretty much enough to get started. So the example I'm going to go through here is probably the simplest thing imaginable for demonstrating parallel speedups, and that's computing prime numbers. So I have this method here called isPrime, which will check if an unsigned integer is prime or not. And then I have a function called countPrimesSerial, which will count all the primes from begin to end, which is from 2 to 10 million. So how many primes we have in this particular range. And it counts them using the isPrime method in a simple loop. And this is what I'd like to parallelize now, considering that it takes a few seconds to run. So if I run this thing, it takes 3+ seconds with optimizations enabled to count, to find out that we have 664,000 primes in that range. So let's parallelize this thing using TBB. Again, the ideas here aren't unique to Intel, but they were among the first to bring them to all platforms in a nice portable C++ way and in a library-only way, without requiring any language extensions to the C++ standard. So in TBB, we have a nice helper called parallel4, which takes a for loop and runs it in parallel. So this will go from begin to end, and then a function which takes an iteration variable, takes an index, and well, checks if it's prime or not in our case. So again, I'm going to use a lambda here, and the lambda just takes, let's call it I. And what I'd like to do here is just, well, count the number of primes I have. So I'm going to put an unsigned count over here, initialized to 0, and eventually print out the whole thing. Now, there are multiple problems with this code, but it is pretty much a one-to-one, it's in one-to-one correspondence to the original loop. So, of course, if prime. If is prime I, then do this, right? So it's pretty much the same loop, except here for is a keyword, and here parallel for is a method call. And if you haven't seen anything like this before, it's getting very, very common in other languages as well. For example, .NET, again, has it for a few years now in a very, very similar fashion, very similar APIs that parallelize loops. So here we're just trying to ask the runtime to go over the iteration space in parallel on as many processors as I have, and just sort of combine the results. So do you see any problems with this at all?
Yes, I see. There is a race condition count variable.
On what?
Race condition count variable should be atomic.
Yeah, so I'm accessing the count variable without proper synchronization, right? Additionally, it won't even compile because lambda functions in C++, these lambda expression over here, are not allowed by default to access external local variables. It would be weird if it were allowed by default. But it can be made possible by just adding a little piece of syntax. Again, I'm not going to go into in depth on lambda functions here, but now I'm telling the compiler that I deliberately want the lambda to be able to modify that count variable. So the lambda should have mutable read-write access to the count variable declared outside of the function. So now we really are accessing a shared variable, and the race condition becomes apparent. And if I run this thing now, hopefully we'll see the race condition in action. Yep. So it did run faster, right? It only took slightly more than a second, but the number of primes is kind of wrong. So there were lost updates. Instead of 664,000 primes, we now only have 653,000 primes. And it's not because the algorithm changed, it's just the lost updates to the shared count variable. There's multiple ways to solve this. TBB, in fact, has a bunch of types for synchronization-enabled primitives like ints and unsigns. But in fact, here we can use a standard C++ solution, which is stood atomic. This is part of C++ 11, of the C++ 11 standard library, and it's a really simple type which wraps another type, like an unsigned int in this case, and makes all operations on it thread safe. In something like an unsigned int, of course, it doesn't use a lock, right? It doesn't use a mutex or a heavy synchronization object. It simply uses the hardware instructions that enable thread safe access to an int. So when I say ++ count here, it will, on Intel processors, just translate to a single instruction which atomically updates an int. So now the code is thread safe, and running it again, okay, so we can see the numbers line up. In both cases, we get the same number of primes in the range, and the time, again, is just about 4 times better than the original result. And that makes sense. I'm using an i7 processor. There's 4 physical cores on the chip. So assuming the runtime understands this and parallelizes my code to run on 4 threads, this is the speed up we can expect. Now, there is some synchronization here, which can break things a little, and that's the access to this atomic shared variable. And there are ways to address this as well. For instance, we could have each thread compute a private count and then combine those private counts to a global count. There's ways to improve this even further, but I just wanted to show you a very quick demo of what things look like. So here, it was just a simple loop that counts things, so the only thing we had to protect was just this unsigned count. But here's a more sophisticated example, not a lot more, but here we have a vector of primes and we want to collect them. right? So I just want to put all the prime numbers in the range in a vector this time, and I just count their number. And so again, the serial version just goes over the range. If something's a prime, puts it in a vector. This could be more sophisticated to implement. I'll start with the basic version. So I'm just going to take this thing and try to show you how we slowly manipulate it to a parallel version. So first, the for loop becomes TBB parallel for. This is just begin. This is just end. And this over here becomes a lambda that takes an unsigned I, and then open brace, close paren, semicolon. Right? So it's a mechanical transformation, really. Okay, and we have a vector, of course, so I'll need that vector to be mutable inside the lambda body. Same problem as before, right? And this time it's not just going to be lost updates. The vector class is probably going to break because we try to mutate it from multiple threads. Let's see what happens. Probably going to crash once we get to that part. Okay, so the serial, the serial version works okay and takes 3.5 seconds. But the parallel version crashes, pointer being freed was not allocated, set a breakpoint to debug, crash, abort, trap, exit. Okay. I could try to protect this vector with a lock. So, for example, we have in C++11 in the standard library a really nice mutex class that I can use. So I could go here and declare a mutex, which will protect my primes vector. And then over here I can say, if it is a prime, then lock the mutex, push back to the vector, and then unlock the mutex. Nothing new here, right? Let's try it now. It should be safe. Ooh. Variable mute has to be captured as well. Okay. Okay, so now the collect version is running, and the parallel version of collect is running, and clearly it's not going to be much faster. So 4 seconds against roughly 4 seconds, and that's the cost of this mutex locking and unlocking that's going on inside. Essentially, there's enough synchronization here to break all gains, to reduce all gains from parallelization. So TBB has another very nice helper for these situations, and that's a concurrent container called simply concurrent vector. It has pretty much the same semantics as a vector, at least the basic operations are supported, so you can enumerate it using begin and end. You can push back, you can get the size of the container, so the basic vector operations are supported. Some more advanced operations are not. For instance, you cannot insert into the middle of a concurrent vector. It would make the implementation more complex. But it's mostly a vector, mostly an append-only container, and it has random access for reads and writes.
Are there any other collections?
Hmm?
Are there any other collections?
Yeah, there are. So you have hash. Yeah, there is a map. Well, there is a hash table, not a tree-based map, but a hash table-based map. Yes. There is a queue. There are more, absolutely, and they are very high quality. So again, Intel they have the tools to optimize the things to Intel processors, and of course it is thread safe, right? That was the whole idea. I don't need locks anymore. Okay, so I'm just going to uncomment the first 2 tests because they're just, making this slower. Right, and so now we see a really nice performance increase from 4.2 seconds to 833 milliseconds, which is even It's super linear speed up really, and we have still the same primes count, so nothing got screwed up in the calculation. Okay, so that's TBB, and that's really scratching the surface of TBB. I mean, I could spend a few hours talking about the other TBB features. Again, there's support for task-based stuff. Spawning work to run in a different thread and then synchronizing with that work in some sophisticated ways. They call it data flow graphs. So you can have a set of tasks and you can have relationships between them, and one task provides output, which is an input to another task. So there's a bunch of APIs around that. Stuff for synchronization, advanced scheduling features, and of course the concurrent containers, which I've just mentioned. And on the algorithm front, Parallel 4 is not the only one there is. Like I've said, there's also support for reduce, for parallel sorting, for transforms. Essentially, you can take the heavier STL algorithms and parallelize them. So if it makes sense, it'll probably have already done it for you. So stuff like sort and accumulate and transform and copy, they all have parallel versions in TBB. And in fact, Microsoft also have similar but not cross-platform features in their own C++ libraries. So you might want to check those out as well. It's called the Microsoft Concurrency Runtime. The APIs are pretty similar.
Is it part of Visual Studio?
Yeah, it is. It is just part of Visual Studio. Yeah. So they have pretty similar APIs, but it's Windows only. And one other thing I'd just like to mention, since we're discussing this whole business of standard libraries, there is a nice proposal to the standard library that Microsoft just recently introduced called the Parallel STL. And this is something Microsoft would really like to see in the next standard of the C++ programming language. And the current proposal is on Codeplex again, and it's called Parallel STL. Not necessarily going to keep the name, but might be part of the next C++, of the next C++ standard. And the idea here is, and again, it's not something you can use in production right now. It's just sort of a glimpse to the future. The idea here is that you can take any STL algorithm, any of them, like find if, remove, copy, transform, reduce, whatever, and you can parallelize it by using an overload. So here's a simple example. Imagine you have a program that uses STL in the following way: sort vbegin vend. So you can parallelize it by adding par. So sort par vbegin vend. Obviously, it's not language magic, it's just library magic. So they're adding overloads of every STL algorithm that take a first parameter called an execution strategy, which can be sequential or parallel. And potentially in the future, this could also be an execution strategy that puts the code on a GPU, or some coprocessor or whatever, or maybe a cluster of distributed machines. But at this point, the Microsoft proposal is just for this basic library behavior where every STL algorithm will simply have a parallel counterpart, which runs in parallel. So kind of like Parallel 4 and Parallel Sort, in the TBB library, we might have something similar in the standard library in the future. This could be really, really nice, because it also means you can change the execution strategy at runtime. So it's the same method name, you can just pick the overload you'd like. Yeah.
Quickly triggers my imagination. You actually have to optimize, for example, look after your functor as well, but if you implement a less operator for sorting,
Mm-hmm.
do you have to?
Well, I mean, it's going to be
Because of your own bespoke less operator.
Yeah, it's going to be the same semantics. So every sort overload will simply have this execution strategy tagged as the first parameter. So you have a sort overload that takes a functor, so you'll have a sort overload with par that also takes a functor. If you have your own less implementation, it's going to use it, yeah, of course.
Does it have to be thread safe itself? I mean, what is really...
It doesn't. It doesn't, because, well, specifically for sorting, it doesn't, because it just compares two elements, it's read-only, and it's invoked for each element, it's only invoked in a specific thread at a time. So, yeah. This can be really interesting, but again, this is just, might be in the future. And in general, I mean, lots of the things we've talked about today could be, maybe, one day, part of the C++ standard library. There's no reason not to. I mean, why does the .NET standard library have support for networking and the C++ one doesn't? Why does the .NET standard library have support for threads, but the C++ one only got it in C++ 11? So there's lots of answers to this question, but right now, as you can see, there is lots of need for external libraries, but these are very high quality. And I could have talked about a few more, just to, name drop. Qt, which is a cross-platform UI library, which works now on mobile devices as well. Boost, obviously, which is kind of the catch-all framework. If it's not in any other framework, it's got to be part of Boost. Tiny XML for XML parsing, serialization, and so on. And there's a bunch of other things you can do with C++ today. And again, one of the things I wanted to show you here is that even if you're not doing C++ for its cross-platform capabilities, all of these libraries and many others as well are cross-platform today. So you can take your common logic, which you have implemented in C++ today, and share it across platforms if the need arises. If you're using portable C++, if you're using the standard library, and if you're using modern standard portable external libraries as well, your whole C++ application could one day be ported to another platform. And we're really seeing the need for that with mobile frameworks and other kinds of applications as well. Here's a link which has a list of additional libraries. Many of the examples I've shown you are from this list of C++ libraries, and there's a lot more there. So if you're looking for a high-quality PDF generation C++ library, you might take a look over there. So C++ development can be, with these libraries, productive, efficient, and portable. Really, cross-platform C++ applications are here, and it's not as hard as it used to be. So we have a few minutes for questions if you'd like. Thanks a lot for coming and staying. I hope you can take away some things to use in your day-to-day work with C++. And I really love the fact that you're still doing C++ today. There's some more C++ talks by me and some other speakers, so please just, I'm looking forward to seeing you. Thank you very much. Thank you.
Thank you.
Yeah. If you have any questions, please go ahead.
On one of your other slides, you said that there are libraries for a lot of other things, and you had machine learning in that list. What libraries would you recommend?
Well, I don't do machine learning. I just put it there because I saw there's a huge list of C++ libraries for machine learning. I am not personally doing machine learning. But
Another speaker as well that we should ask. He said expert machine.
Cool, yeah, and if you'd like, I could do some digging around because we have at our company a couple of experts on machine learning. I'm not sure they're doing C++ a lot, but we could try. Yeah.
You'd be sharing the source code that you've written today.
Oh yeah, absolutely. This you mean my code?
What you've been typing
Yeah.
today,
Well, the slides you should get as part of the DevWeek app or something. They aren't there yet, I think, because they just copied them over in the beginning of the talk. It will all be on my blog as well and on my Twitter. And if you don't find it, then just contact me. I mean, in a week or so, I should have it all sorted out. Yeah. Okay. Well, thanks again. Enjoy the rest of it.
Thank you.
Thank you for coming and not going to the Xamarin and Angular and TypeScript stuff. I really appreciate it. Good morning. My name is Sasha, and we're here for the cool C++ libraries talk. I hope you are all C++ developers. You are, yeah, okay? Or at least doing some C++ occasionally on the side, something like that. Good. I do have a couple of questions for you so I get a good picture of what you're dealing with. Have any of you already been using C++ 11 or C++ 14 features? Yes, no, not all of you, some, okay. There's a couple of other talks on modern C++ at this conference. I think I have one tomorrow, 9:30, on modernizing your C++ code, so using new cool C++ features. This one is on libraries though. So what I tried to do is just take a few nice libraries that I've been using occasionally in the past, and some other libraries which I'm really into and I teach a lot. So some of them I use every day, some of them I use more occasionally, and sort of build a talk around a few demos, just illustrating how these libraries can help you in your day-to-day C++ development. And I hope even if you're using lots of C++ libraries already, some of these will be new to you, or at least the core concepts will be useful. And the really nice thing about modern libraries for modern C++ is that they are all cross-platform, they sort of are expected to work everywhere, and they're all open source as well. These were important criteria for me as I selected the topics for this talk. Another question I have, are any of you doing cross-platform today? So is C++, is the reason you're doing C++ that you have cross-platform needs today? Yeah? Some other languages from other testing frameworks for .NET, for Java, it should all look very familiar to you. It's the standard arrange, act, assert, chain. You assert various conditions, and then there is a test runner which can tell you which tests have failed and why exactly they failed. There's a download link down there. I'm going to give you the slides, obviously. And it's a cross-platform framework, so let's take a look at a quick example of using Google Test on OS X. So here's the first demo. I've got a header file here, which has a small, tiny, can you all see the text? Great. Which has a small, tiny library, header-only template library, which can print containers recursively. So it detects whether something is a container. If it is a container, it prints out the container's elements. If it isn't a container, it just prints out the thing. So if you give it an int, it should print the int. If you give it a vector of ints, it prints out all the ints in the vector. And if you give it a vector of vectors of ints, it should be able to enter the internal vectors recursively. So there's a bunch of templates here, but eventually it all boils down to two methods. The one over here just prints out an element to the output stream, and this one over here enumerates a container and prints out the elements to the output stream. And I mean, it's an interesting implementation in itself, but let's take a look at the tests, because that's what I'm trying to show you here. So I've got an include for my header-only library, and then an include for Google Test, for the Google Test framework, and then I just have a bunch of tests. And the test macro declares a test with a test suite and then test, yeah? Okay, some of you. It's really weird, but C++ does have this whole portability thing built in. You have C++ compilers for, for microwaves and for smart cars and for everything. You can run C++ literally everywhere. And so, everyone's getting excited that you can do C# on Android and iOS. Well, you could do C++ on Android and iOS for years. And then you can do JavaScript on, I don't know, these Internet of Things devices and run Node on Raspberry Pi. You could run C++ on Raspberry Pi from day one. So, I mean, if you know C++, there's such an incredible breadth of devices and platforms that you can run on already. And the libraries I'm going to talk about today, well, at the very least, support Windows, Mac, and Linux. And some of them also support the mobile OSs and other weirder platforms as well. Essentially, wherever you have a C++ compiler, probably most of these libraries are going to work as well. Now, in terms of operating systems, Windows, yeah, okay, and you too?
Yeah.
Windows as well, okay. Linux, okay, thank you, my friend. Android as well. Okay, so as you see, I have a Mac, and some of the demos are going to be on Windows. Most of the demos are going to be on OS X. But they all work on all platforms, like I've said, and I've actually tried most of them, and they do. So what kind of things I have in stock for you? So I tried to sort of, address as many needs enterprise developers might have today doing C++. So we've got a library for HTTP client and server. building HTTP clients and servers in C++. It's a really cool library by Microsoft called Casablanca, or the official name is the C++ HTTP REST SDK, which is a little more boring, but it's called Casablanca. Open source, Microsoft, and cross-platform, so it's a weird combination, but it's really a nice library. Google Test is the other. It's a unit testing library for C++, obviously by Google. Are any of you doing unit testing in C++ today? Great, so what are you using? Google Test. What's that? Uh-huh. CP unit and Boost. I was sort of expecting that. Great. So I'm just going to introduce Google Test to you in case you'd rather use that. And if you're not doing any unit testing in C++ today, then at least one of those libraries you guys mentioned should be worth looking into. Third one's Socky. It's anyway, it's the way I pronounce it. It's a SQL database framework, sort of like an ORM, really, object relational mapper, which has drivers or providers for most popular SQL engines today, including some NoSQL engines as well. So it supports, obviously it supports Oracle and SQL Server and Postgres and SQLite and MySQL, but it's also got support for some more exotic databases as well. Any of you using Socky today?
Did you mention Oracle there? I was writing.
What was that?
Does it support Oracle as well?
Yeah, it does. Yeah. So any of you using Socky today? No? Okay, it's a really nice library. Then we have protocol buffers, which is another Google project, which has to do with serialization and communication, transferring data in the most optimal form, as well as storing data for later use. It's a really nice library, which is not only cross-platform, it also supports a bunch of different languages. It supports C#, it supports C++, of course, and it supports a bunch of more lightweight languages like Python and Perl as well. There's also a bunch of non-official bindings for a bunch of additional languages. So it's really sort of, it's becoming the official language for all internal communication within Google, and lots of people outside of Google are using it as well. Anybody using protocol buffers today? No? Okay. And finally, we've got Intel's TBB, Threading Building Blocks, which is a pretty massive framework for concurrency and parallelism. It's the only one in this list that has sort of a dual license. It's GPL if you use it for open source work, and it has a commercial license if you intend to use it for commercial projects. The rest are usable in all kinds of commercial software, so they don't have any sort of restrictive licenses attached. Now, this is just a brief selection. I obviously could have picked another 6 frameworks to show you today. There's an abundance of good, high-quality C++ libraries today. And again, like I've said, most of them were from the start and are today open source. And so you can obviously review the source, but you could also contribute if you really like some of the things you're seeing. So with that said, let's just get started with a quick review of Google Test. So some of you already have unit testing frameworks for C++ today, so I'm just going to give you a quick review of what a Google Test suite looks like, and then we'll move on to other projects which you should probably find more interesting. So Google Test is a unit testing library for C++. It's obviously made by Google. It's open source, and it's used by a lot of projects internally at Google, including Chromium, for example, and LLVM, which is the compiler toolchain by Google, used widely today across multiple languages. It's a really mature testing framework, which is, if you're coming from